A groundbreaking moment just unfolded in orbital launch technology as China's private firm LandSpace completed a full static fire test of its stainless steel reusable rocket, the Zhuque-3. China's Zhuque-3 reusable rocket passes a key test to rival SpaceX, marking a historic step toward the nation's first fully reusable orbital launch. This milestone places LandSpace among the world's most advanced private space companies. The successful static fire test of the Zhuque-3 marks a pivotal step in China's private spaceflight journey. Conducted on October 20, 2025, at the Dongfeng Commercial Space Innovation Pilot Zone in northwestern China, the test showcased the performance of the rocket's 9 Tianke-12A engines. These engines, powered by liquid methane and liquid oxygen, fired while the rocket was securely anchored to the ground, producing full thrust without leaving the pad. This test allowed engineers to assess ignition, shutdown sequences, and the coordination of all propulsion and ground systems under near-launch conditions. The Zhuque-3 stands 66 meters tall, roughly equivalent to a 20-story building, and is made entirely of stainless steel, a design choice that enhances heat resistance and structural strength during re-entry. It's a two-stage vehicle with a reusable first stage and an expendable upper stage, following a configuration similar to SpaceX's Falcon 9. In its reusable mode, the Zhuque-3 can lift to 18.3 metric tons to low Earth orbit, while in its expendable version, it can carry around 21 tons, numbers that bring it close to the Falcon 9's 22.8-ton payload capacity. LandSpace designed the rocket for vertical takeoff and vertical landing operations. The company's next steps include a vertical integration test, during which engineers will assemble both stages, conduct fueling rehearsals, and finalize pre-launch verifications. Afterward, the rocket will be inspected and prepared for its maiden orbital flight, which is expected before the end of 2025. The static fire milestone demonstrates more than just engine performance. It proves the readiness of Zhuque-3's integrated launch system. It confirms that the engines, tanks, control systems, and ground operations can work together in harmony. Passing this test transitions the rocket from a prototype into the flight campaign stage, signaling that the hardware is capable of achieving orbit and recovery. The test also confirms LandSpace's growing technical maturity. Following several developmental flights of its previous rocket, the Zhuque-2, the company has refined its methane-fueled propulsion system, making the Zhuque-3 a highly efficient and reusable heavy launcher. The Zhuque-3's success marks a major turning point for China's private aerospace sector. For years, the reusable rocket market has been dominated by a few global players, most notably SpaceX. Now, China's LandSpace has entered that same league with a rocket capable of delivering similar payloads and reusing its first stage. This isn't just a technological milestone. It's a sign that global competition in reusable spaceflight is about to intensify and evolve faster than anyone predicted. With a payload capacity of around 18 tons in reusable configuration, the Zhuque-3 sits close to the Falcon 9 in performance. It gives China a domestically developed rocket that can support both commercial and national missions, from deploying large satellite constellations to resupplying orbital platforms. In reusable configuration, LandSpace aims to cut launch costs by as much as 2/3 compared to expendable rockets. Such cost efficiency could drastically expand the nation's access to orbit and attract more commercial customers. This move also supports China's ambition to rank among the world's top 3 aerospace powers by 2030. Until now, reusable rockets have largely been developed by government-backed programs or established Western companies. LandSpace's achievement shows that the Chinese private industry is capable of innovation at the same level, proving that rapid prototyping, bold design choices, and iterative engineering are paying off remarkably well. For the global market, this introduces new dynamics. With more reusable rockets entering service, launch prices could decrease, increasing the frequency of missions and opening space access to smaller satellite developers and research institutions. It also diversifies the sources of launch supply, reducing dependency on a few providers and driving technological evolution across the board. Another crucial element is LandSpace's focus on sustainability. Methane fuel burns cleaner, producing fewer carbon residues and simplifying engine reuse. Combined with stainless steel construction, this ensures better heat tolerance and lower maintenance between flights, factors that determine long-term economic viability. Despite the milestone, significant challenges remain before the Zhuque-3 can become a routinely reusable vehicle. The static fire proved the engines and integration work as expected, but the next test, the first orbital launch, will be the true measure of success. During that mission, the rocket must execute a flawless liftoff, stage separation, controlled descent, and landing of the first stage while the second stage completes orbital insertion. Every step introduces risk and demands precision from thousands of sensors, valves, and onboard computers working in perfect synchronization. Landing a 66-meter booster requires precise control of thrust and orientation. It must withstand re-entry heat, deploy landing mechanisms accurately, and touch down safely on either a drone ship or landing pad. Even minor anomalies can result in the loss of the stage. Furthermore, achieving reliable reuse means not just landing once, but doing so multiple times with minimal refurbishment between flights, ensuring turnaround time rivals global industry standards. LandSpace has stated that Zhuque-3 is designed for reuse cycles. Achieving that goal depends on how well materials endure repeated thermal stress and mechanical loads. The company will need to validate this through extensive post-flight inspections, stress testing, and data analysis after each recovery to refine design margins. There are also market and operational pressures. LandSpace is competing with both state-owned companies and global heavyweights who already have proven reusable fleets. To stay competitive, it must deliver on reliability and consistency. Every failed recovery or delay affects credibility. Launch demand will also play a crucial role. With multiple private and national rockets emerging, the market could become saturated, pushing companies to differentiate through cost, precision, and reusability rates. Despite these hurdles, the outlook remains optimistic. The upcoming orbital flight, expected between November and December 2025, will mark China's first attempt to recover a large reusable rocket from orbit. If successful, it will redefine what private Chinese companies can achieve and pave the way for more frequent, sustainable access to space. Beyond that, LandSpace plans to expand the Zhuque-3 family, potentially developing larger variants and adopting a rapid reuse model, similar to what SpaceX has demonstrated. If those plans materialize, we could witness a future where launches from China occur weekly, drastically changing global launch logistics and setting new standards for cost efficiency and speed. The Zhuque-3's successful static fire test marks a milestone in reusable rocket technology, demonstrating how China's private space industry is rapidly catching up to established global leaders. LandSpace innovation, from its stainless steel design to its methane-fueled engines, proves that the age of reusable orbital rockets is becoming a worldwide phenomenon. The road to full reusability is still challenging, but the momentum is unstoppable. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, SpaceEyeNews.com. Thank you for watching, and see you next time.